Okay. Fair enough. Cool.
So I guess the first question really is, have you done interfaces or abstract classes before?
Nope, I'm completely new to them.
Okay.
Yep.
So I guess would it be helpful for us to just go over like, I guess giving you a crash course into them? It's
Yeah,
basically an
just a small
extension off of
introduction.
inheritance.
Nice.
So I guess Hannah, I guess you can start with abstract classes.
Okay, so you still want to like put it like that?
Yeah.
Okay, all right. Okay. So first we're going to talk about abstract classes. And so abstract classes are used when, so like last week how we talked about in polymorphism, how you have superclasses and subclasses. You want to use abstract classes when the subclasses are more important than the superclass. Because basically what you can do is you can make your superclass an abstract class. Because an abstract class, basically the difference between that and a regular class is that you can't instantiate an abstract class. So you can't make an object out of an abstract class. So it serves more as a blueprint for creating other subclasses with it. So one example of this is if you wanted to write a program where you were using different shapes like triangles or a square or a circle. And so you might define a superclass called shape because all of these different things, triangles and squares and circles, they would all probably have similar methods, like maybe get size or draw shape. They would all have lengths, things like that. But these methods would all be implemented differently because obviously how you draw a circle would be different than how you draw a square. But at the same time, since all the methods are similar, it's a good idea to have an overarching superclass like a shape class. But the thing is, you would never actually create a shape object in one of these programs because you would want to create either a circle or a square or a triangle. You would never want to create just a shape. And so that would be a good example of when you would want to use an abstract class because you're never actually creating a shape object. Does that make sense so far?
Um, I get the part where you said you create an abstract class to make the subclasses more relevant, right?
Mm-hmm. Here, I can show you more clearly. One second. Let me share my screen. So, okay. So this is just the ebook. Okay, so let's say that we wanted, like I said, to create a class, or not a class, sorry, a program that draws different shapes, like in this picture. So such as squares and circles. Um, so you would probably want to create a rectangle and an oval class to represent these objects. But since a rectangle and an oval would have very similar methods, such as drawing the rectangle or drawing the circle or figuring out the area of the rectangle or the area of the circle, you probably want to have an overarching superclass that has these methods that you can then change the implementation for in your shape subclasses. So, for example, finding the area of an oval would be different than finding the area of a rectangle. You need two different implementations. And so that's when you want to have a superclass and then make the rectangle and the oval subclasses. But the thing is that since we are always drawing a specific shape, if we made a shape superclass, you would never actually create a shape object. So as we can see here, we're creating a public abstract class simple shape. And so to declare an abstract class, you just need the keyword abstract. And so within an abstract class, you can define methods such as here's a diagram. If we had the simple shape abstract class, you can define methods such as draw, and you can also define different fields, but you can't actually instantiate the object. Instead, you instantiate its subclasses, so line or oval or rectangle. And so these all have this method that is in the superclass. It's just that you couldn't actually instantiate a simple shape object. So here's an example. If we try to create a simple shape object, so here S, and we run this, we're going to get an error that we declared it as abstract. And so it cannot be instantiated.
So we mean it cannot be instantiated. You mean it cannot be initialized at all because it's abstract, right?
Yes. Whenever you use that abstract keyword, you cannot create an object for it.
So whenever it's abstract, that means no objects. Wow.
Yes. Basically, you want to declare something as abstract to serve as sort of a blueprint. So
Yeah.
like, you would never actually want to create a simple shape object. That's not the point of making this class. Instead, this class is serving as a blueprint for your different kinds of shapes. So your rectangle and your circle.
Yeah.
So it's like the outline for the program, right?
Yeah.
Because when you think about it, what if you're just going to define a shape? You can't really do that.
What define a shape?
Yeah, because like we have specific types of shapes, but if I ask you, just tell me plain out what a shape is, it's really hard to describe because it's an abstraction, really. We kind of use it to describe other things.
Oh yeah. Now that you think about it, if you think about geometry, it's like very abstract.
Mhm.
Like just the shape, but then it has all these different angles and trig functions and stuff. But it's
Mhm.
still very abstract though.
Yeah.
Okay, let's see. What else? So like I said, abstract classes can have constructors and fields and methods, just that you can never instantiate an abstract class object. Also, a lot of times abstract classes will have an abstract method, and an abstract class doesn't have to have one, but if you do have an abstract method, that basically just means that you don't have to provide the implementation for it. But if you do provide that abstract method, and you have a subclass of that class, it still works the same way as if you had a regular superclass, not an abstract superclass, that you still are going to end up having to implement that method in the subclass. So if we go back to our simple shape, so if we had declared draw to be an abstract method, public abstract draw, we would still have to provide the implementation for that method in line and oval and rectangle. Because whenever a class has an abstract method, it has to be declared as abstract because you aren't finished implementing the whole class. That abstract method doesn't actually have any code written for it. You're just defining the blueprint for that method. Does that make sense?
So since it's an abstract method, well, it's abstract, that means those field variables like 0.1, 0.2, and color will not be instantiated, right?
Well, so 0.1, 0.2, and color are all just variables. They're not methods. So you don't, like, they're not objects, so you don't actually instantiate them. They're just fields. But so like when you create an oval or a line or a rectangle, once you instantiate that, then you can set those fields equal to something.
But since they're not instantiated, you can't set them equal to anything, right?
Yeah, exactly. Yeah, they're just like defined as a blueprint. You're not actually creating them.
Wow. A Java blueprint, right?
Yep, exactly.
Okay. That sounds nice.
Yep. So yeah, I think that's it for abstract classes for just a basic overview. So does that all make sense, what we've talked about so far?
Yeah.
Okay. So now Asta's going to talk about another thing called interfaces that are pretty similar to abstract classes.
Well, that's what I'm working on now on one of my worksheets. I'm
Hey,
almost
perfect.
yeah, going right into interfaces.
So what do you know about interfaces then?
I'm not sure. It's the first time I like saw it. Like I don't really know much about it or nothing at all.
Okay. So basically, so you know how abstract classes are basically that the subclasses are more important and they're kind of like the blueprint for an object.
Yeah.
So an interface is basically a special type of abstract class when it's not really the object that you care about, but the methods. So
Wow.
so the same idea that an interface cannot be it can't be instantiated, and it's also that they basically exist for other classes to use them. But the really important thing about an interface is that you care more about what it can do. It's a collection of common behaviors. So um, you basically are separating then what an object can do from what an object actually is. So, like, for instance, you could let me see if the if the ebook has a good example. Because I know sometimes in theory it doesn't make sense, but once you see an example of it, it's a lot clearer. It doesn't have an example. But so basically, think of a vehicle, right?
Yeah.
So a vehicle can be really vague because you can have like a boat as a vehicle, you could have a bicycle, you could have Heelys, like anything could be a vehicle. But and so that's why it wouldn't really work to have it as an abstract class because it's a whole idea that's really vague because all you really care about is the fact that a vehicle can move and you can use a vehicle to move things. And you could have a vehicle that has like a move method and a maintenance method. But the important thing is that is between different types of objects, the way you move and the way you like maintain the vehicle would be really different. So you would just basically leave it in the interface as just a move method and just a maintenance method. So that when you go and implement the interface in like a car object, or sorry, a car class, then the car will have its own special move method and its own special maintenance. And then when you implement it in like a Healy's method, it'll have its own move method and its own maintenance method. Does that make sense?
Yeah. So interfaces, it's like a special abstract class
Mhm.
where it focuses more about the actions or the behavior of the blueprint, right?
Exactly.
But for this one, you're not really using abstract, right? Because you, as you said vehicle was like very vague. So I don't think you need to imply abstract in there because a vehicle can almost be almost anything,
Mhm.
down to a boat, to like a rocket or anything.
Mhm. Yeah, exactly. And so there are some key things to note about interfaces. So when you actually write an interface, let's see if they still don't have an example. Not happy. Oh, no, they do. They do. Okay, cool. Let me share my screen so that it'll make sense what I'm saying.
Okay.
Uh, Here. So this is in the ebook. So they have a little tiny interface here that I actually skipped over because I thought it was a method because it was so small. But you can see that you declare an interface just using the keyword. So be public interface checker. And notice here, this is actually the method that is going to be implemented by different classes that use the checker interface. So you don't actually need to write public abstract Boolean check object and stuff because it's basically implied that if you're in an interface that the method is not going to be implemented inside the interface and it's going to be public. So you can actually just ignore that part and just start with the return type and the name and then the parameters. So like if we had a vehicle class, it would be public interface vehicle, and we would have the brackets, and then we'd have like void move or void maintenance or something like that.
Wow. So like I
So
said, Boolean, it would be like void move, right?
Exactly.
Wow.
So, one thing that's really important is that in a interface in general, you can have multiple classes that implement that interface. So, like, you could have a car class, a boat class, a bike class, a rocket class. All of them can implement checker. And also, you could have the car class implement vehicle. You could have it implement object, or you can have basically you can have multiple. One class can implement multiple interfaces. Does that make sense?
Can you repeat that again?
So basically, w- um, so for abstract classes, because
Yeah.
of inheritance, you can only have one direct subclass. Or sorry, you can have only one direct superclass. Um, so you can only have like one parent. So um, if you say like public abstract shape, simple shape, and then you have a subclass called rectangle, you can only have that rectangle as a subclass, a simple shape. It can't be both a subclass, a simple shape, and something else. So for interfaces, that's not the case because we're talking about like methods and behaviors and stuff. And so an object can have lots of different types of behaviors. And so because of that, you can have one class implement a ton of different interfaces all at the same time.
Wow.
Does that make sense?
So it's like if you have one abstract, you can go into like a whole bunch of interfaces, right?
Sorry, repeat that.
So you were trying to say if you have like an abstract class, you can go into a bunch of interfaces.
No, it's basically that a class, like any type of class, like a public class, can implement multiple interfaces.
Oh,
So, like, there's an interface called comparable, which basically enables you to compare two different objects of the same type. So, like, you could compare strings to see which one has, like, the longer length, or you could compare cars to see if they're both like Toyota Camry or something like that. So you could have your car class implementing vehicle, and it could implement the comparable interface. And that would be like A-okay. It would be completely fine. Does that make sense?
so if you have like a public class, like public class vehicle,
Mhm.
that means it has access to multiple interfaces, right?
Uh, what do you mean by that?
Um, what I mean is, I thought you said if it's like a public class, like without abstract, it can have access to interfaces like special abstract classes or
Yeah,
blueprint.
you would just have to directly implement it. So you'd have to like say in the method header, and I'll type it on the chat here. So say you have like public car implements comparable. It's comparable comma, right? If it's implementing multiple interfaces,
Um,
or is it implements comparable and then implements again?
I'm not sure.
Yeah,
That's good.
yeah, I don't think I've really seen it. Let me just Google and check really quickly. Uh,
Yeah, like usually a class only implements one
yeah.
interface, but like it's possible for it to implement multiple ones.
Mhm.
Wow. So,
Yeah, it usually does not implement more than one.
what do you mean, like a regular public class?
Yeah,
It doesn't even have to be like a public class. It's just that like any class can implement multiple interfaces, but can only have one abstract class that it is extended from.
it is comma, by the way. Found it.
Uh,
Yeah. So basically, if you have this in your method header,
Yeah.
it'll say that you're implementing both comparable and your implementing vehicle.
Wow.
So it's basically the point of what we were saying is that even though it's not commonly used, it's totally possible for this to happen, which is
Oh,
what makes it really different from abstract classes.
Oh, you mean like just a comparison between the cars, right?
No, just that you can have multiple interfaces
Ah,
being
so
implemented.
is comparable like a reserved word?
Comparable is its
No.
own special interface. It's actually like a class that Java provides you that you can use.
Oh, it's in the Java library.
Yeah, it's its
I see
own
what you're saying.
interface. Yeah,
It's like string.
yeah.
Oh,
Yep.
so it's already built in. That's pretty amazing.
hmm Yeah, so I actually have to go. So sorry about that, having to dip out early. But I
It's
guess you
okay.
can carry the rest, Hannah.
Yep.
Okay.
All right. See you later,
Bye. See
Yep,
ya.
Asta.
see you, Asha.
Okay.
Bye.
Yep.
So, now that we've kind of covered the basics of interfaces and abstract classes, I'm just gonna go over again. I know we already sort of talked about it a little bit, but the main differences and similarities between them. So, like we said, abstract classes should be used for an object that is application specific, but incomplete without its subclasses. Whereas an interface should be used when there are methods that are suitable for your program, but could easily be applied to applications in a variety of programs. So abstract classes are more used when you want to use it as a blueprint for a whole nother class. So more when you want to use it, if you talk about like objects or nouns in Java and methods are verbs, you want to use abstract classes in terms of when you are talking about the nouns of Java, so the different classes, versus interfaces should be used when you want a class to implement multiple methods.
So it's like basically use interfaces for a variety of programs can use verbs or actions, right?
Yes, yeah. So, so for example, how the example in the ebook, how it had an interface where it was one method and that method was just check. So like it checks if something is true or false. Obviously, that's not like a blueprint for a class. That's just a blueprint for a method that a lot of different classes of a lot of different programs might possibly need. And so that's why you would make it an interface.
Wow.
Yeah. So then an interface cannot provide any implementation of its methods while an abstract class can. So once again, if you provide implementation for an abstract class's methods, then it's just like a regular method. But you can also choose not to provide implementation for an abstract class's method and then declare that method as abstract. And then an interface cannot contain instance variables, while an abstract class can, because once again, the abstract class is like a blueprint for a different class. An interface and an abstract class can both declare constants. And the most important thing is that it is not possible to create an instance of an interface or of an abstract class. So does that all make sense?
So abstract class is a blueprint, while interface is just what can you call it? Or
So, okay, I guess a better way to explain it, which I think I was maybe trying to say earlier, but I kind of didn't get across very well. So an abstract class is more of a blueprint for another class, while an interface serves as a blueprint for different methods.
ah,
So
so
different functionalities that you want your classes to have, while an abstract class is the blueprint for the actual class.
So abstract's the blueprint for the actual class, while interface is the blueprint for functionality for multiple classes, right?
Yes.
Okay. That makes perfect sense. That means the interface is going to be filled with methods and behaviors.
Yes.
Okay.
So, okay. So last week we talked about polymorphism, and so abstract classes and interfaces represent polymorphism very well, because an abstract class, like we talked about earlier, is basically just a superclass. So you can have an is a relationship. So like the example we talked about earlier with the shapes, you can say that a circle is a shape or a square is a shape. So,
It's like it extends from shape because the superclass is shape, while the subclass will be circle or.
am I back? Sorry about that.
Oh, that's okay.
Sorry, what were you saying?
So I was saying that you said circle was a shape and square was a shape. So circle or square basically extends from shape, and shape is the superclass, while the subclasses are square and circle, which means they have to have one parent class for that superclass.
Yep, exactly. So then the next way that they relate to polymorphism is like we talked about last week, how you can declare an array to be of a superclass type, but then you can fill it with the different subclasses. You can do the same thing using an abstract class, where you declare an array to be of the abstract type. So you can declare an array of shapes, but then you can fill it with the different subclasses. So you can fill it with rectangles and circles and squares. Does that make sense?
Yeah.
Okay. So that's basically all the material that we're going to cover for today. So now we're just going to go through a couple of questions
Examples.
and examples. Yeah. Okay. So first question, below class ABC doesn't have a single abstract method, but it has been declared as abstract. Is this correct?
Oh, you're asking, is this correct?
Yes.
Okay. It didn't declare. No, it's not correct.
So it actually is correct. Like we talked about earlier, an abstract class can, if you have an abstract method, it has to be declared as abstract. But if you have an abstract class, it doesn't necessarily need an abstract method.
Because it's already applied up top, right?
Yes. Versus like if you have an abstract method, that means you're not providing implementation, which just kind of implies that it's a blueprint. Like you're not filling the whole class.
Like this right here is a blueprint, right?
Yes, it's a blueprint, but we filled these methods, which is fine. It's just that, so like this class is declared as abstract, but it technically doesn't have to be. Like it's okay that it is, but like it technically doesn't have to be. What wouldn't be okay is if we did have an abstract method and then we declared it as a regular class.
Oh, what you're saying is like if you said public class ABC and then you said abstract void first method, right?
Yeah, exactly. That wouldn't be okay because if you declare a method as abstract, that means that you're not providing any implementation for it.
It's just not acceptable and it goes against conventions of Java, right?
Yeah. Yep.
Okay, that makes sense.
Yep. Abstract classes may or may not have abstract methods. Next question. Why is the class below showing a compilation error?
Because you initiated abstract class, that means there's no point to say abstract void, abstract method. So you can just leave it as a void and be okay. The abstract within the class is redundant.
Okay, so kind of, but not exactly. So
The logic is terrible, right?
so what we were talking about in the last question, when you declare a method as abstract, that means you're not providing any implementation for it. But since we are providing the implementation for this method, it shouldn't be declared as abstract.
Oh. So if we have a body, then it shouldn't be declared as abstract.
Yep, because you're providing implementation, so it is no longer a blueprint. It is a full functioning method.
Oh, you mean number 2 is a full functioning method, right? Because it has a body?
Yes, this is a full functioning method.
Then what would this be? This would be like an interface now because it's...
No, it can still be an abstract class. It's just that this method should not be abstract.
Oh, but since it's abstract, that means it's fully functional, right?
So, sorry, say that one more time.
I said because of the abstract, does that mean that's fully functional?
Since it's... One second. Am I still sharing my screen?
No, I don't see it.
Here, let me try again. Okay, it's not letting me share my screen. Okay, that's okay. I can just keep going through it by talking. So basically, an abstract class can be fully functional. It's just that if you have, it's kind of like a one-way thing. An abstract class can be fully functional, but it doesn't have to be. But if you have a class that is not fully functional, it has to be abstract.
So that one was fully functional, but there was an abstract, like just anyway.
Yes. But then the problem with it was that you declared an abstract method that was fully implemented. I'm sorry, I'm like, my throat kind of hurts. I'm sorry that I keep coughing. But
Okay.
yeah, but so the problem with this is that when you have an abstract method, that can't be fully implemented. But when you have an abstract class, now I kind of see your confusion. An abstract method should not be implemented at all, whereas an abstract class, it is okay if you have implementation for things. So it's really just that the method cannot be implemented at all. Does that make sense?
Yeah, I can't see you.
Yeah, I'm sorry. I know you can't see it. It's my video is not working. Yeah, I'm sorry.
It's okay.
Okay. So I'm just gonna try to paste the questions into the Google thing and see if that works. Okay. So in the Google chat, I'm going to give you the headers for 2 different classes and tell me which class can be instantiated, Class A or Class B?
Class B could be instantiated because it doesn't have the abstract reserved word.
Yep.
Because Class B is A, so that's the inheritance piece. And when you say extends, it's inheritance, so it can definitely be instantiated as long as the abstract is not there.
Yep. Okay. So now I'm going to paste into the chat a snippet of code. So you have an abstract class A with an abstract method add, and then you have
wow,
extends A.
Nice. I see the explicit parameters.
Yep. So, however, this code snippet has a compilation error. Can you figure out what is wrong with it or how to fix it?
Oh, you mean the one that goes abstract class A all the way down to class B extends A?
Yep. So if you
Okay.
were to try to run this code, it would give you a compilation error.
Is it because you said abstract integer add? Because when you say abstract integer, is that like the reserved word integer? It will not be initialized or instantiated at all, right? And the
No,
variables.
not it. Okay. So basically, the integer here is not actually a class. That's just what that method is returning.
Oh.
It's just if you ignore that word abstract, you would have int add, int a, int b. And remember, when you declare a method, that first word before the method name is what it returns. So this method is returning an integer, which isn't an object. So the problem with this code snippet is that since class B extends A, it has to implement this abstract method add. So you have to
Oh.
have in class B int add, int A, int B. You have to provide the implementation for it, because if you don't, then class B has to also be declared as abstract because it will be inheriting this abstract method from class A. Does that make sense?
So the reason why it's wrong is because if you say class B extends from A, it's going to inherit its abstract properties, or
Yes, exactly. Because a subclass inherits all of the methods from a superclass. So it's inheriting this method add. And since add is declared as abstract, unless we change it in class B, so unless we override that method and provide implementation to make it not abstract, it's still going to stay an abstract method to class B. And so since class B would have an abstract method, class B would have to be declared as abstract also.
uh
Does that make sense?
yeah.
Okay. Let's see. This one's kind of long. I don't know if I want to. That might be hard to copy and paste. Okay, next question. I'll paste it in the chat. Can we write explicit constructors in an abstract class?
I don't think so. No, because when you say abstract class, objects cannot be created, and what you're saying basically what a constructor is, you have the left side. You're basically saying like, let's use this as an example. Example one ex1 equals new example one. Then you have the parentheses semicolon. So you're creating a new object, and then in the abstract class, there's no creation at all. So we can't do that.
So this is actually kind of a trick question. You would probably think that you you can't have a constructor in an abstract class, and your thinking was I mean, it makes sense what you were saying, but you actually can implement any number of constructors in an abstract class. And the reason
Like,
for this is because when you have that subclass that extends your abstract superclass, then you can use that
oh,
constructor for the subclass. So even though you can't instantiate the abstract superclass, you can instantiate its subclasses. And so therefore you can have a constructor for the abstract superclass.
it's like a way to bypass it without going to the direct source. So if you wanted to declare an explicit constructor in an abstract class, you have to do it in the subclass, right?
Yep.
Wow, it sounds like a way of bypassing or to make the rule bend to like your will or make it go your way. Wow.
Okay. So the next question, and I don't think we went over this, So you can just kind of try to guess. So here I copied another snippet of code, abstract class, abstract class. And
Why?
then and then it has a private method called abstract method. So there's something wrong with this class. Can you try to guess what it is? Even
Is
though
it
I
be-
don't think we went over this.
Is it because it says abstract class, abstract class? Should it just be like this once and then private, abstract, integer? Why do you need to add private? Like you still want to access it anyway because it's in that
Exactly.
class.
That
Like
is
why?
wrong with it. The method should not be private because you can't instantiate an abstract class object, and so you would never get to this method ever. And
Well,
so it shouldn't be private.
this is actually fun.
Okay. The other questions are all pretty long. Let me try sharing my video again. Yeah, it's still not working.
Wow.
So okay, I think since my screen sharing isn't working, I think we might just stop there for today. But next week, our webinars are just going to be practice questions, and so we can go over more complicated practice questions with
For the interface and the abstract, right?
yeah. But I think that we're gonna stop
Nice.
there today.
Okay.
All right. So do you have any last minute questions?
Yeah, it was kind of weird because like the group me, right? I had to calibrate it on my laptop, and now I'm able to get the group me messages on my laptop, so that's pretty cool. And yeah, I'm surprised nobody came to the webinar. It was just me, Asha, and you, and you keep going in and out. I don't know what's wrong with Merlin's Wi-Fi. It seemed just like a reliable source. It was like the Russians got their hands on the internet and just intercepted everything. Hey,
Yeah, I'm sorry we've been having technical difficulties, but we're trying to get by with them.
yeah, it's okay. I know you guys are gonna figure out eventually, like just have like a stable source of internet. Because
I
Asha
hope
keep
so.
trying to use a wire connection and it still doesn't work.
Yeah. Hopefully it'll get better. Maybe maybe our computers need a spring break also.
Yeah, oh yeah, your spring break initiates on Saturday, right?
Yep.
Wow. So wait, when do you guys come back to school? The 27th or the 26th?
We come back next Sunday. I'm not sure what day that is.
Wow, it sounds like your spring break is very short.
Yeah, it's a week, which is fine.
Yeah. I know that your winter breaks are magical because you get like a whole month off. So
Yeah, we get a very long winter break, which is really nice.
yeah.
Yeah. All
I
right.
gotta really look at that ebook because it looks like it's just pretty interesting.
Yep, the ebook has a lot of good information to look at.
And then with the worksheets I've been doing, I think I finished about 40 or 50 worksheets and I'm almost done with the packet. Because I think it goes all the way up to like arrays and like some more crazy stuff I haven't learned yet, which you're gonna like basically tell us in the later webinars or 101s. But yeah, that should help me with like the next 3 or 4 worksheets with the abstract and the interface. I can just go back to this video and just keep running the loop and just it should be nice.
That's good. All right. Well,
Yep.
I hope you have a good rest of your night, and I'll see you later. Bye.
Yep, you too. Have a good night, Hannah.